Hello, everyone. Welcome to AWS Made Easy. Ask Us Anything. This is episode number 14 with me, your host, Stephen Barr, and co-host Rahul Subramaniam. Rahul, how are you?
Doing very well. Hey, everyone. Welcome to yet another episode. I'm glad we're going strong. Up to 14. So, yeah, very, very exciting. How's your weekend, Stephen?
Really good. We went up to the San Juan Islands, which are these little islands, a group of islands up near the Canadian border, and just had a really nice time exploring. It's really green and lush. Went fishing and swam off the dock and all this kind of stuff. It was really nice.
That sounds like a lot of fun.
How about you?
Good. By the way, just before I jump and to tell you what my weekend was like, how's the weather in Seattle? I heard there's a crazy heat wave.
Cloudy and gray, and everyone's relieved. Oh. It was hot yesterday, but today it's a bit cloudier.
Oh, glad that there's some respite. So at this end, it was a fairly relaxed weekend. Did nothing. I got to spend a little bit of time doing some electronics work. Like I said, I'm trying to brush up on a little bit of my robotics and electronics building. So this side of my office looks crazy filthy with everything on the table. I have my breadboards, I have my components, I have my chips, I have my microcontrollers, all of that strewn all over the place. But yeah, I've been trying to build some stuff, and I taught my elder one, an 8-year-old, how to solder.
Oh, cool.
And his soldering was shockingly very professional.
I think that is a challenge not to burn your fingers. So that's fantastic that he was able to do that.
Yeah, I mean,
good quality results.
The quality was, I was very pleasantly surprised, and he seemed super keen on doing all the soldering from then on. So yeah, it was a good, fun, relaxed weekend at this end. Still a little hot, but signs of rain. So
fantastic.
Okay, so we have a pretty packed agenda today.
All right. Well, let's dive right into our first article. Here we go.
Okay.
There we go. And I put the article in the chat for everyone to follow along. The first one is Amazon Elasticache now supports AWS Graviton 2-based T4G, M6G, R6G instances in Europe and R6GD in Europe, Paris region.
Yeah. So it looks like the Gravitons are everywhere. The way Amazon is pushing these Graviton chips, the deployments are at massive scale pretty much everywhere. I think what I heard was that over 50% of the processors that they're actually deploying in all the different data centers are Graviton processors, split right now between the Graviton 2 and the C7Gs, which are the Graviton 3 processors. But I think the rollout is huge. Most importantly, what they're doing with their managed services is absolutely amazing. They're taking every one of the services that they manage themselves and natively supporting those on Graviton. And most importantly, the pricing for the services that are offered on Graviton is lower than the one that you see on x86. So it's, they're pushing those Graviton chips really, really hard.
And for something like Elasticache, where it's a managed service, was there any reason why you'd even care what the architecture was, as long as it performed the way you wanted it to?
Really, no, because Elasticache doesn't even let you, get into the nitty-gritty details of the system. It's accessed via the API, so you really wouldn't care. You just want a performant Elasticache instance that is cheaper.
I mean, the only thing, maybe if you were working on some weird DEC alpha system with big endian encoding and you were caching binary, I can't really think of a reason why you care about the architecture of this. So if it's cheaper, then yeah, go for it.
Yeah, and this is Elasticache as a managed service, right? I mean, someone who's on Elasticache shouldn't really care. The first thing that they should be doing is turning off just changing the instance type for
Yeah.
Elasticache.
So this is a
very
no-brainer. This is cheaper. It's really hard to argue why you wouldn't do this.
Correct. And I think we discussed this on a previous episode. We'll try and find that particular episode. Elasticache is significantly cheaper when you move from x86 to when you move from x86 to ARM. I think the specific versions are when you move to Elasticache 7.1 or I'm trying to remember all the versions. But I think it was Elasticache 6 is only on x86. But once you go from 6.9 onwards, the migration becomes seamless to ARM, and the performance improvements are really, really big. They are like 60% or more. So you would actually end up spending way less on those instances than you would otherwise. Yeah, it's right there. When Redis version 6.2 and above on Graviton 2 based R6G nodes, they have 5x more capacity.
Wow. Looking at the pricing page and looking at the different cache class instances, right? So we've got the R6G. This is the Ohio region. R6G at that hour.
Pick an R5. Let's pick an R5 2x large.
Yeah. So
which is the 8-core and 52 gigs of RAM. That's 8 cents an hour. 86 cents an hour.
Yeah. And then I guess comparable would be this, the R6G.2x large.
Correct.
Which slightly cheaper, a much better machine.
82, but 60% better performance.
Let's see. Yeah, wow.
So you could probably get away with using a smaller instance given the performance. You probably don't need that massive an instance.
And here's the R6GDs. Okay, so here's the R6GD.2x large, $1.56 an hour, 10 gigabits.
Yeah, but then you get a significantly greater SSD attached to it.
Well, it's interesting. So this is a very simple announcement in one sense, right? It's just a different instance type, but at the same time, it's very free money you kind of just put on the table by AWS as part of the Graviton adoption. You're right. I think in the future we wouldn't even want to know the architecture if it's a managed service. But I guess at this point it's good to know, and it gives us peace of mind. Okay, what are we running on?
I really wonder if at some point of time all of these managed services would only be available on Graviton. Like, as they move to serverless on all of these services, I guess it'll all be on Graviton and you wouldn't care about what's running under the hood. So the more stuff that moves to serverless, that conversation kind of doesn't exist anymore. But the way they're rolling out the Graviton, I mean, it's absolutely mind-boggling.
It's amazing to think of the physicality of the process of having to produce these. Do we know where they're produced? But I imagine they ship these as completed racks that have the Nitro cards, Gravitons all ready to go. Get this to the data center, get them installed, integrate them into the whatever manages the region level, and then have it be ready to be offered. It's pretty incredible. They can roll out all of these things at different regions across the globe.
Correct. And it makes sense for AWS to do this. I think last week we were discussing this with Jeff as well. The fact that on one rack, they're able to pack in 3 of these processors on a single motherboard. So it's 1 Nitro card and 3 64-core processors. That's staggering. It just makes sense to do that for the entire data center.
Yeah,
rolling it out in full steam.
It lowers the power footprint. I'd imagine that as you switch to these, like we talked about yesterday, as you looked at that carbon footprint calculator, it would lower a bit as well, just because these are using so much less power.
That's actually right. The carbon footprint calculator, 60%. So I think there are multiple dimensions to this. One, the power consumption overall is way less, right? So you're going to end up saving or being greener on that front. And I think the numbers were like 40, 45%. Sorry, that was also 60% more green. They have 60% lower power consumption overall. Then the next dimension is if the performance of these chips is 60% better on a workload like Elasticache, then you have that win as well, which means that you would end up using 60% lesser resources to keep things up and running. So this just has a multiplier effect on so many dimensions. You could end up cutting your energy bills or your contribution to the carbon emissions by 70-80% easily by switching over. So it just makes sense for organizations on so many different fronts. And you save money doing it. Usually for a lot of these exercises where you get such massive wins, the cost associated with these are usually crazy high. In this case, you save money. Usually crazy high. You have lower energy consumption and performance is better. So I don't know who loses.
Yeah,
I guess it's Intel.
Yeah, okay, someone loses, but that's okay. They had a pretty good run, and they'll come back. It's part of the competition, right?
The cycles. Yeah.
I was trying to find the highlight of putting in the. Oh, here we go. I'll put this into the chat now. This is that segment from last week where we're talking about Graviton and AWS's metrics for energy consumption. So that just put that in the chat. And that reminds me, everyone check out our highlights on Twitch, and we also post them on our Twitter feed. So make sure to follow us on @AWS Made Easy on Twitter. We post highlights from previous episodes. And it's a great way to kind of just get reminded about the things we've talked about. We have some really good segments, and taking them in all at once is a lot. But then when you actually break it down into the highlights, I find this to be really helpful. Yeah, we had a really good discussion, and I re-listen to them because there's insights that come up in real time that we don't think about. So I enjoy listening to them after the fact. All right. Well, awesome. So thinking about this, we're trying out a new system here. So our overall grade of this particular article, what do we think about this?
So I think this is I'd put this at a 4 out of 5. And the reason why I'm picking 4 out of 5 is I wish they had more data about how seamless it is to migrate over.
Yeah.
And if there were like a two-step or a single click or a two-click migration that's provided out of the box from your existing Elasticache instance, I think that would be neat. Like just 2 more screenshots over here saying, here's how you do it, would make such a massive difference to adoption. Right now, this just feels like like I say most blog posts from AWS look like legalese. This just feels like another, cookie cutter announcement, like a press release.
Yeah.
If this was an announcement blog, having those 2 steps would be great.
Yeah, I agree. I'd just be able to click and say, well, here's how to transition, or even an example of how to change your CloudFormation template or whatever it is to transition over to the Graviton instance. But then overall, I think this is, overall it's a win. Obviously, we're big fans of Graviton, but the contents of the post itself, it'd be nice if there was a little bit more information on how to transition.
Yep, completely agree.
All right.
And then we have the other rating that we were doing, right?
Yes.
Whether this
does this
simplifies or complicates?
I think this is an obvious simplify.
Yeah, I think this one is pretty straightforward.
There we go.
Wow, we've got new graphics.
Our designer, she's working hard behind the scenes to really up our production value. So this is simplified. This simplifies life. We get less power, more bang for your buck. All you really need to do is change an instance type. How do you go wrong? All right. Well, anything else before we transition over to Lambda tiered pricing?
Yeah, let's move on to that.
All right, here goes. AWS Lambda announces tiered pricing, and I'll put this article in the chat as well. There we go. So, tiered pricing for monthly Lambda function duration in gigabyte seconds of using. The additional pricing tiers are discounts on aggregate monthly on-demand duration. So, looking at the article, they give you okay. The tiers are at the first 6 billion gigabyte seconds, and then an additional 9 billion gigabyte seconds. It goes down by about about 10%, and then
about 20%. Yeah.
And then again, it goes down after your 15 billion gigabyte seconds per month.
Yeah, actually, this announcement is way simplified. I think it gets a little more complicated. So can we pull up the Lambda pricing? Yeah, let's pull up the Lambda pricing. So this is really the announcement over here. So you have the new tiers. This is a much better way to understand how the pricing goes. So first, while you can, I mean, it's just obvious. The ARM prices are lower than the x86 prices. Like, look at the duration column, and it shows you how much it's going to be, how much they charge for every GB second. And the difference, though, which I'm curious about, is that they keep the slightly higher pricing for a little longer on the ARM. So for the first 7.5 billion GB seconds, you are in the most expensive tier, and for x86, that's down to 6 billion.
You really wonder if that extra 1.5 billion gigabyte seconds for that, what is this, 100,000ths of a cent? Was it really worth adding that extra, a whole other, doubling the size of this table?
Correct. That part just seems a little, it just feels weird. And can you imagine the complexity you have to add behind the scenes for billing? Because then it's not a simple tiered pricing. Then you have to worry about how many billion GB seconds per month you're consuming. Okay. So I'll step back. I'll say two things. Number one, I don't know how many customers use 6 billion GB seconds. I haven't done the math on how many hours that is.
That would be really interesting for them to put, is in the blog post today. We estimate that this will impact our top 30% or 50%, or if this is only for the top 5% of users who are heavy users. It would be interesting to know who this impacts.
Correct. And I think the numbers, like at first glance, when you look at 6 billion GB seconds, that number just seems insanely high. And my first thought goes to, I don't think we'll ever touch that kind of number. But I guess if you start looking at it in the terms of number of hours that you're going to actually run this, it might be significant.
I mean, I've got some, and we'll see this in the behind the scenes episode next week. I've got some Lambda functions to deal with video encoding that take on the order of, a low amount of minutes in some cases. So that adds up. I mean, 6 billion is still a lot, but it adds up. And I don't think.
So let's say we had a concurrency of 1,000, right? There are 1,000 lambdas that are running all at the same time within an org. So that's 6 million. So the 6 billion, divide that by 1,000, you're left with 6 million. And then divide that by 3,600. And that's about 1,600 hours, 1,700 hours. That's
okay, so a moderately big organization would hit this.
Actually, this is not incredibly large. Like anyone running like 3,000 or 4,000 lambda, but this is on a per month basis. Actually, that's still pretty large. You would need to run almost 50,000 lambdas concurrently to hit this number.
Yeah, so it would be really interesting to know, okay, we estimate that this will save money for X% of our customers.
Yeah. That'd be interesting to know.
Well, all right. I don't know if there's too much more to talk about here. Let's see, nothing else changes. But if you're using, I think, a lot of Lambdas, then as you use more, it gets cheaper on a per unit basis. 3 tiers, and then different tiers, slightly different tiers depending on if you're on x86 or ARM.
Okay. Can you go back to pricing? There's actually one more table at
Yeah.
the bottom that I wanted to bring up. Yeah, no, the table on top where it compares x86 pricing
This one.
and no, the one below that.
Below.
The one below.
Okay. There's data transfer, Lambda Edge.
No, not Lambda Edge, the one on top. There's a section that talks about per second. There's a table. Yep, right there. That one.
Okay.
That one.
Oh, I see.
Okay. So this one slices the same thing by MB and gives you the per millisecond pricing. And if you compare the x86 price versus the ARM price, you will find that there's about a 20% price difference. 20%?
Now, you think there's room for one more column in this table?
And I don't know if you noticed, but now the pricing changes on from a per second basis to a per millisecond basis.
Okay, price per 1 millisecond. Price per one. Oh, okay. No, price. It's still price for 1 millisecond.
Yeah, but then all your other stuff is in terms of GB seconds.
Oh, I see. Okay, so then you just have to deal with the extra couple of zeros.
Could they make this more complicated to comprehend?
So then, so how do we rate this article? Because on the one hand, you don't have to do anything; nothing really changes. Right. But on the other hand, the way they communicated it could be a lot more simple.
Yeah, I think I'd give this one a 1.
Okay.
Or a 2, maybe. I feel a little generous.
Here we go. 2 clouds.
Give it 2. But I think they've just complicated the communication to a point where a lot of customers are going to say, I know what my... Yeah, this is definitely very, very high on the complexity alert. A lot of customers are going to be scared of figuring out what their net costs are going to be. Like, they've been using Lambdas, they know what their current costs are. And this doesn't provide a clear indication that they should move. It's a complex calculation that someone has to perform to figure out whether this is actually going to be cheaper for them or not. My instinct tells me it's going to be about 20% cheaper.
Yeah.
But they've just represented this in such a convoluted manner that I don't think anyone takes away that.
And these multi-tab tables, we got to get rid of. This is only if you have a lot of different columns. But this doesn't make any sense. So, all right. Well, but it's a good. Okay, so overall, good thing, but a lot of extra complexity in the communication.
Exactly.
Cool. Well, let's take a quick break, and then when we get back, we're going to be talking about QuickSight.
Public cloud costs going up and your AWS bill growing without the right cost controls? CloudFix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
All right. Long title on this one. Amazon QuickSight launches API-based domain allow listing for developers to scale embedded analytics across different applications.
Yeah, so this one is actually quite interesting. Unlike most other services at AWS, QuickSight kind of evolved in a completely different manner. The way it is integrated with the AWS suite is completely different. It feels like a single tenant application that's just offered on the console rather than being a native API first service, which is what pretty much all the other services are. The mechanism of authenticating users or bringing them on board is done in a completely different manner. You have to authorize users on the QuickSight app. Fundamentally, as you start embedding these applications into other or these dashboards inside other applications, you run into the problem of multi-tenancy. Right? You have one account, one QuickSight dashboard that's templated that you want to use across multiple tenants. You want to be able to do different permission schemes and so on. That just becomes insanely hard. And a lot of this was not available via API earlier. You had to go into the console and set it up. You had to go into the QuickSight dashboard and go to settings and go set it up there. So it was kind of all over the place. And I think given that now there's an API to, you can do domain allow, we have to try this out a little bit more. But I think this is the mechanism by which you'll now be able to afford or be able to serve multi-tenant solutions that use QuickSight dashboards. So this is actually a really big deal for anyone embedding those dashboards inside. If you're just using it within your org, as simple dashboards where someone logs into the console, not that big a deal. But the more you're embedding these dashboards inside applications that you're shipping, you need, to create these domains and control access. This is your multi-tenant solution.
That's really interesting. This is it almost reminds me of how Amplify felt initially when you had the Amplify console. It's this user model is detached from everything else I'm doing.
Correct.
I need 1 second. Hold on, I need to close the window. 1 second. Oh, apologize for that. Someone started a leaf blower outside. Elon Musk, if you happen to be watching, please invent an electric leaf blower. Add to the Tesla lineup. That would be so much appreciated.
Yeah. All so, right. Multi-tenancy is really a big thing for most of these applications. QuickSight has the scale, but if you can't serve multiple, thousands of customers in different domain and be able to partition and segment customers who access these, it's really not, valuable. The other problem that QuickSight has, and hopefully this resolves it, is any of the dashboards created in that account, you basically you can decide what dashboards a particular user has access to. But if you have edit access, you pretty much have edit access to most stuff. And you have the ability to look at the underlying set of dashboards. So the permission schemes are a little convoluted. And, the more we can segregate customers, the better it gets.
Got it. Well, I think this is a fairly straightforward announcement.
This is fairly straightforward. Given that they have the blog going with it, which actually covers examples of code and the request responses, I'd actually give this a 4 out of 5. QuickSight is complicated as a product, which is why I'm taking away one point from it. But I think from an article standpoint, they've done a pretty good job of trying to communicate it effectively and make it easy for someone to try it out, use it, and figure out what to do with it. So I'll give it a 4.
Yeah, definitely. If you saw this come up on your RSS feed and it was relevant, you'd right away jump into the blog post and just have a look.
Correct.
The blog post, like you said, they link right to the blog post. The blog post has examples, screenshots, a lot
Correct.
of it. Yeah.
And this is literally the thing that I was hoping that they would do for, for the first article we discussed, like Elasticache. That should have been like a half a page blog post that said, go to your console, click this button, change your instance type to a Graviton instance and save up to 60%.
So then overall, do we think this gives us some simplicity? It seems like you said, it's fundamentally not a simple thing, right? Because it's access to data within your organization. But being able to access this by the API, I would think, makes the administrator's life simpler.
I absolutely agree. For embedded applications, you have to do things via API. You cannot do this from the console. I think that expectation's, ancient. So this definitely simplifies.
Excellent. All right. Well, and I guess that's a good thing to keep in mind for other teams is, right, to have that blog post. There's nothing that's better than an example and a screenshot. That's and like there's one API request that really clarifies a lot more than a big paragraph could.
Yeah, completely agree.
All right. Well, anything else before we move on to Comprehend?
No, I think this one is fairly straightforward. We can move
All
on
right.
to the next one.
Let's do it. All right, this one's a really fun one. This is AWS Comprehend lowers annotation limits for training custom entity recognition models. So to go over this one, there's a bit of jargon that we have to go over. So Comprehend, right? This is part of the text recognition framework that can look at things like sentiment and named entity recognition. So named entity recognition is if you have, say, proper nouns or quantities or things that are of interest. It's basically trying to extract the structure of your document and what are the key things that you're thinking about. Now, with custom entity recognition, what we're saying is, okay, Comprehend can look at things by default like places, right? There's a finite list of places that we can talk about, and that's straightforward across all text. But then there's domain-specific things. We'll show some different examples in a bit. Like, for example, video games, or in pharmaceutical, it could be the names of certain drugs, and there's actually medical comprehend for that. Or any type of domain-specific language where you have a corpus of text that's specific to your application that comprehend wouldn't necessarily pick up. Or like even Amazon services. That's a whole other body of vocabulary.
True.
So to train a comprehend model, it used to require 250 documents and 100 annotations per entity. So entity is the type of thing that you're looking for. The 250 documents, quite a bit. This is a pretty big reduction. This is 25 annotations per entity type, with as low as 3 annotated documents. So 2 orders of magnitude drop. That's pretty big. This is
Yeah,
this is
that
a big
really
deal.
is. And I guess their algorithms that train these models are just, improving by leaps and bounds. And it's pretty amazing what a service like this can do. Imagine, you wanted, to get alerted. You have different news streams that are coming in, and you wanted to get alerted anytime anything was said about a particular company or a particular person, or, you wanted to figure out whether there was any notification about an event or something that was happening today or tomorrow or on a particular date. It would be virtually impossible to write a system that could filter through all of that, but tools like Comprehend or services like Comprehend can help you navigate through all of that. It can also figure out whether there is content that is not safe for work or things like that. There are tons of amazing things that Comprehend can do for you, and it's really easy to get started with it. But do we want to show how Comprehend works?
Yeah. Should we just jump right into it? That's a great idea.
Yeah.
All right. Well, then with that, we want to introduce a new type of segment called Let's Code. So let's introduce this segment. All right. So, Rahul, should we switch to your screen and you can show us?
Let's
All right.
let's go ahead and do just that. By the way, I have one complaint.
Yeah.
That graphic shows me in a suit. I can't remember the last time I was in a suit.
All right, we will have that fixed for next time.
Great. Okay, so for our viewers, we've created this new repository called AWS Made Easy. It's a public repository where we hope to post some real live code that you can try out, you can play around with. Hopefully, it will help you get started with these AWS services a lot easier. And we will try to bring in a few new snippets of code every single week as part of this conversation. Feel free to ask questions. This is live coding exercises. So we will do our best to keep up with your questions, or feel free to contribute to these repositories as well. This will all be public. We just created it today, so it's probably going to take us another few hours to clean it up and put it out there. This is currently available in the EP14 branch. You can follow along right there, or you can just try it out.
All right.
Okay.
Well, I posted I'll put it in the banner, and there's a link in the comments. All right, let's go ahead.
Perfect. So we are going to use something on DevSpaces. DevSpaces is our AWS-based Graviton-enabled IDE in AWS. It gives us Visual Studio Code in the browser. And instead of talking about it, I'm just going to show it to you. So we have a little browser plugin that allows us to click and get right into DevSpaces straight from our GitHub repositories. And it basically pulls in a container in AWS, gets everything started. It's Visual Studio Code, as you can see in the browser. It's just loading up a bunch of extensions. It'll load up all the code. It'll get everything up and running for us. And I think we are up and running. We'll just give it a second.
And so in that second, it's allocated some resources, clone the repository, set up the Visual Studio Code, set up this temporary URL for you to access your workspace, all that in that 2 or 3 seconds that you've been waiting. It's pretty neat. I take it for granted now that I have completely disposable dev environments.
No, absolutely. It's crazy how easy it makes life. Okay, I'm going to let me see if this happens live. How far can I go? This much?
Yeah, that's fine. We can even do full screen. You can go a lot wider, but that's fine.
Okay, so let's start with this. Okay, so this is a very, very simple piece of code that I wrote up a few minutes before this session. What we're doing here, this simple Python code, it uses the Boto3 library, and it's importing JSON because JSON is the format in which we process all the responses. I've written 3 very simple functions out here. The first one is called detect entities, and let's look at the Boto documentation here. So the Boto documentation is really, really simple. All you need to do is to get started with Comprehend, import Boto3, tells you how to instantiate the client. And then here are all the amazing methods that you can start using to bringing, all of these neat insights. So today we're going to talk about 3: detect entities, detect key phrases, and detect sentiment. So let's start with detect entities. Okay. So in detect entities, you basically pass it some text and you decide what language encoding or what language you're using. There's a code for it. EN is English, ES is Spanish, FR is French, and so on. And it's really that simple. And then in response, you'll get a score. You will get the type. So it'll give you a classification. It'll tell you whether this entity that it found in the text is a person, location, organization, a commercial item, event, date, whatever, right? There are a bunch of different categories that it has. So it'll give you all of that. And it'll give you the text that it found. And it'll tell you where in the file this is. So there's the begin and end offset, which tells you exactly where in the file that particular entity exists. So you can look at it, pull it up, and then use it as you please. So let's just run this code. Okay, so I am going to need some permissions. So we need some AWS credentials. I am going to take myself off screen for just a second as I put in my credentials. Give me 1 second here. Okay, and I'm coming back on screen. So my environment should be set up, hopefully. I haven't tested it out. But let's get right into it. So I'm going to get into the folder where I have all of my files. The first thing that I'm going to have to do is install all the dependencies. That was a typo. Okay, so this is installing all the dependencies that we need to run Boto. Great, everything should be ready to go. Let's just run the script. So for right now, we should be actually pulling up raw text. So if you remember our very first article where Amazon Elasticache supports AWS Graviton T4G instances, I literally just copy pasted that entire text and dumped it in here to see what it finds. Let's just look at the code and make sure that we are doing some interesting stuff. So for now, we're just detecting the entities. That's the function that I'm calling over here. And then I'm going to just dump out the JSON response that comes out of this simple function call. Okay, so let's do Python comprehend. Okay.
Credentials, huh?
Ooh. Okay. I think I need my credentials expired. Word of advice for anyone working with AWS and AWS related services: do not use your keys directly. It's always a good practice to use temporary keys because you never know where you might check it in or make it available to the rest of the world, depending on whether you're doing a demo like this or doing something else. Give me just 1 second to get a new set of keys and generate.
No problem. Yeah. Well, that makes a lot of sense to use as temporary keys. I had a few close calls with checked-in keys, and luckily GitHub catches those now. But it's a pretty bad practice when you get that commit failed. You put a private key in a repository, and it's easy to say, okay, I'm doing some testing. I'll do that later, and then you commit the file, and your AWS account is a Bitcoin mining machine. That can get very expensive very quickly. So good idea, even though it can be slightly more cumbersome, to use those temporary keys. I think that's a really good practice.
Now I just have one other problem, which is that I've lost the window. I've lost my window where I had, oh, there we are. Great. Okay, just give me 1 second to set up my credentials.
No problem.
And we should be good to go here. Sorry, give me 1 sec. Okay, so we're going to try this one more time. Sorry, I'm in the wrong folder. Okay, this is where things start getting interesting. So here are all the entities that it detected. So the first one was the text Amazon. In fact, let me bring up the raw text right here. So Amazon, it detected as an organization with a 99% accuracy, or these scores are out of 1. So it seems pretty confident of that. Elasticache, it guesses at 66% score that this is a commercial item. AWS is an organization. Graviton 2 is a commercial item, right? There are some other very interesting ones. So Paris is a location, because this announcement says that this was launched in Paris and Milan. I think there's Milan in here somewhere as well. Europe is a location. These different instance types, R6GD, that's other, it doesn't know how to classify that. Then you got dates like August 4th, 2022, which is the date of this blog post. You'll see this right up here on top. So it does a pretty neat job of identifying all the key entities. Now, let's say you wanted to create an index of all of your documents so that it's searchable. Just figuring out what these key elements are, you can take all of this and start creating good, neat indexes out of this. That would make searching all this content a lot easier. Now, here's another very interesting feature. If you wanted the searching to be a little more interesting, you can start using a new or another API called detect key phrases. So instead of just looking for words or single entities, you can start looking for key phrases. Because sometimes you want natural language based querying, you want to look for these phrases. So let's just try that out. Let's see what we get. This time when we run this with key phrases, you'll see that you got long sentences like the Graviton2 based T4G, M6G, R6G, and R6GD instances. Or if you go up a little further, it says the general purpose M6G, or it figures out that this is some quantity and that's relevant. NVMe based SSD storage is another key phrase that you might want to search for. It's not just storage, it's not just SSD, it's not just an NVMe. The fact that it's NVMe based SSD storage is important for good natural searches. So provides a pretty neat way of collecting all this information without you having to write much code at all. I mean, this effectively is one line of code. Yeah, it looks like 4 because
you're just wrapping. You're wrapping
one line of code there, one line for Boto, one line for this. Like 5-6 lines in total, and I didn't really have to do very much to get all of this, and it probably cost me a fraction of a cent.
Sitting through all this data science and machine learning, lectures and learning about TF, IDF, and learning with the n-grams and the bigrams and building up indexes and manually labeling all this stuff. And even if you went through all that work and did all of that, it wouldn't be nearly as good as this because it's been trained on so much data.
Exactly. Last, I am going to try this one, and I was writing this up just as we were starting this episode. I wanted to really understand how well it does on sentiment. Okay. So I pulled up this Top Gun Maverick review that someone had posted and brought it into the code. And so actually let's copy this and replace this raw text with that. I'd be really interested to see what it does on the entities. Again, live coding. I don't know if this will work. The test for the Comprehend team. Let's see.
Let's see
how well it does on detecting the entities. Okay, let's see what entities it found. It found Top Gun. It found Maverick. That's the title. Then tonight is a date. Tony Scott is a person. 80s is also a date. And that's pretty neat.
The neat thing about that is that it's not just looking at syntax, but it's looking at the way. What do you call it? It's looking at the embedding. So it's saying way back in the 80s or back in the 80s, and that embedding, like you wouldn't. It's not just looking for number S, right? This is not regex. This is embedding and context and how these particular phrases fit in and how they're used in the language.
Correct. One of the best, this one is interesting. One of the best is a quantity. I think this one, movies, I don't know in what context, or it may be one of the best movies. This one seems off. Tom Cruise is a person. Cruise is a person. Let's see. Any other interesting ones here?
Well, and there's again, if we were talking about a cruise ship, it would figure that out based on the context.
Correct.
He's talking about Mr. Cruise, or Cruise did a great job, where cruise ship wouldn't make sense, even though it's the same word.
Exactly. Okay, let's try out key phrases. See what it produces for key phrases. By the way, a shout out to the Dev Spaces team. As you can see, I'm doing this all live in a browser. Okay. This Dev Spaces makes it so easy to go straight from code without having to set up the environment. The environment is all provided as infrastructure as code. So, and by the way, if you don't provide it, the default image that it uses has support for 25 languages right out of the box. So you really don't need to do very much. You can get started right away and start playing around with code.
And all you need is a GitHub ID. I put a banner up showing where to try it out. Literally, you don't have to sign up with us. You just put in your GitHub ID and authenticate that, and right away you can just use Dev Spaces on a Graviton 3. It's a hell of a lot easier than SSHing into a box and getting it all set up and remembering to close it down. It's just right there, ready to go. I love this product.
Correct. And you close the browser, it's ephemeral, so it goes away. So literally for every PR, for every commit that you want to look up, you can create a completely separate environment, run it up for the 10, 15, 20 minutes that you're going to play around with it, and then just kill it. Or it'll die automatically. So it's really, really simple. Okay, let's come back to Comprehend. So look at the key phrases. These are actually pretty neat. 80s people is the key phrase. It wasn't just 80s the time, but it was the 80s people. Everything else, friendship, loyalty, romance, and okay. Old school action movie, playful winks and embellishments, absolute best, supporting cast. It's pretty neat. Original Top Gun leather jacket.
That's really cool.
Okay, now for the hard one, to be able to figure out sentiment. Okay, I'm going to do line by line sentiment over here because I want to really understand whether it's able to provide that level of detail. So let's go ahead and do this. Okay. Oh, I dumped everything. Sorry. I dumped everything in one, but we can turn this into a line by line one. Okay, so this was everything, and it's 94% positive, or a score of 0.94. So yeah, very high confidence that this is a great positive review for the movie. And it was that simple. Can you imagine doing this for your internal documents, your blog, or to figure out sentiment of all of your employees or the communication that they're having, or to give feedback to someone, when you're sending out, communication internally, you want to make sure that that communication is neutral or positive, and you're not communicating negatively because that's not productive. Imagine this being a filter to your email before you send it out. Like,
it's interesting. Some people don't recognize that their tone can be misperceived, and it's so being able to say, okay, before I send this email, this is being read as more negative than I intended, when it should be neutral, right? That is really neat to be able to get that feedback from a essentially objective source.
Yeah. One concrete data point I do have is that Comprehend does not understand sarcasm yet.
Well, many people don't. So
that's true too.
I think that's a pretty high bar.
Yeah, agreed.
That's some of the most complicated things that are out there.
Correct.
Well, here, I'll share my screen real quick. I know we've got about 5 minutes. I wanted to share along the custom entity part. So what I did to train a custom named entity is I looked at video game names. So just to show the path of how this works, the steps are basically this. First, you want to upload some training data to S3. Then you can annotate that data using SageMaker Ground Truth. And then you train the model, and then you can test the model, and then you can run it in an endpoint. So to show what that looks like, I'll start with Comprehend. So I'm going to open up a new tab here. So if I go to Comprehend, custom entity recognition. Let me go back. Oh, okay, I see. I have this one set up for real-time analysis. So this is going to use my model. I'll show you how this model got set up. Let's go to the training data. Okay, so I put some training data here, and it's just a few text files that are articles from Blizzard press releases or video game press releases. So if you look at what this looks like, similar to Rahul's, it's just text. And the next thing you do is you go into SageMaker Ground Truth, and you can annotate that. And let's see if we can find that. So it basically looks like Mechanical Turk. And what you get at the end is you get a list of tags of all the different things of all the different entities. So you work through all the different words, you highlight them, you say, okay, this word is a video game name. And now I'll show what it looks like at the very end. So I've trained the model, and now I can say I want to do a real-time analysis on my game recognizer endpoint. Let's clear this text, and let's go over to here we go. Here's Activision. And here's a press release for Diablo 4. Now, I didn't train it on this particular game, but let's paste in the text. Okay, we're in the right character limit, and let's hit analyze. And there we go. So it came up with Diablo 4 is a game name. Diablo 3 Reaper of Souls is a game name. So it was able to figure out, and again, I didn't train it on these particular ones. It's not looking for words in the text. It's looking for the way that those particular types of entities are talked about, right? I had a lot of fun playing blank, although I thought the gameplay itself was difficult, or however it is. That's the kind of structure it's picking up. And I trained this on literally 5 text files and spent 20 minutes annotating them. So this, back to the original announcement, if I was to do this with 250 documents and 100, it wouldn't have happened. I wouldn't have been able to play with it. But 3 documents, 25 annotations, I could power through that in a few minutes. And so it was really neat to be able to see that this model, even though it didn't have very much training data at all, was able to work and produce some useful output.
No, this is pretty neat. To be able to do this without much heavy lifting, without really having to know much about ML or NLP or all the algorithms and keep pace with the advancements that are happening on that front. I mean, this is absolutely amazing. So, leverage it is my advice. These are some really amazing services that are at your disposal, cost almost nothing to use. And the fact that you can run this, you can go create custom entities, custom models for your data, which is specific to your domain, I think opens up so many amazing use cases that, I can't wait to see what people come up with.
I've got this little personal Raspberry Pi based dashboard, and it has an RSS feed. And I want to try, okay, can I monitor an RSS feed and a certain entity that I'm interested in whenever that comes up to alert me on the dashboard? And that should be able to extract that entity or even negative sentiment around that entity.
Yeah, by the way, we use Comprehend behind the scenes to keep pace with all of these announcements that AWS is making and to bring to our attention the most important things that we can bring back to you. So, we use Comprehend a lot. And yeah, we'd love to hear from you about your experiences and your feedback on it.
All right. So final ratings on this article. I think this is what do you think? I would think this is a simplifies.
Yeah, absolutely. This simplifies stuff. I mean, it just makes the product so much more usable from an end user standpoint.
Yeah.
I totally get what complexity must have gone behind the scenes to create these models that can just work with a fraction of the documents and annotations. So, kudos to the team. Really neatly done. And the quality of this article, pretty neat as well. It's pretty straightforward. And I do believe, I wish that they just added there is a blog post. So
yeah,
we should be, there is a blog post.
On it, so it went dark. Let's see. There's the blog post. You get example data.
Correct.
You get endpoint. You get
so it walks you through exactly step by step what you do to get started with it.
Yep. Link to a sample data set.
Correct. So I'd give this a 4 out of 5 as well.
You're going to 4? All right. I was thinking 4.5. All right. Well, let's see what let's see what earns a 4.5 in a future date. Yeah, solid 4. Good example, sample data. Great.
Yeah.
All right. Well, I think that wraps us up for today. Anything else, Rahul?
No, we look forward to the next episode, which will be episode number 15.
And that's going to be a behind-the-scenes look at how we manage the live stream using our own tools, using serverless, and it's going to be a lot of fun. Looking forward to sharing that with you.
Yep, I'm really looking forward to learn as well.
All right, we'll see you all next time.
Stuff behind the scenes.
All right.
Great.
All right, have a good
See
week.
you all.
Bye-bye.
Great, guys.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money you can save? Visit cloudfix.com to schedule a free assessment and see